Have you ever looked at a set of numbers that just didn't make any sense? Today, we're going to crack a simple puzzle that seems to break the basic rules of math. And in doing so, we're going to unlock a really powerful way of thinking.
Okay, so let's kick things off with a little mystery. A university polls 50 students about some new activities they're planning. The results come back and, well, something's a little off. The numbers, as you're about to see, just don't seem to add up.
So here's the data they got back. We know for a fact there were 50 students in the survey. And out of those 50, 30 of them said, yep, we want a music activity, and 22 of them said they wanted a theater activity. Seems straightforward enough, right?
But hold on a second. 30 for music plus 22 for theater, that's 52 choices. How on earth is that possible when there were only 50 students to begin with? Where did these 2 extra phantom students come from? To figure this out, we need to learn a new language.
And this new language is all about how we organize groups. It's a super powerful idea from math called set theory, and it is the absolute key to making our numbers make sense again.
So what is a set? It's actually really simple. A set is just a collection of things. Think of it like a box. The items you put inside that box are called elements, and we list them inside these little curly braces to show that they all belong together in that same group.
And a set can contain literally anything. It could be the set of primary colors, and here you see them in Portuguese. Azul, amarelo, and vermelho for blue, yellow, and red. Or it could be the set of vowels, or the set of odd numbers less than 10. It's really just a super precise way to define what's in a group and what's out.
But, just putting things into groups isn't all that exciting. The real power comes when we start doing things with these sets. And these simple operations are exactly what we need to crack our survey code. First up, we have the union. Its symbol kind of looks like a U, which is handy because it's all about uniting things. You're just merging groups. So if you have a set with the numbers 1 and 2, and another set with 2 and 3, their union is simply 1, 2, and 3. It's anything that's in set A or set B.
Next, we have intersection. And you're going to want to pay close attention to this one because this is the real key to our puzzle. Intersection is all about finding the overlap, the elements that are in both sets. So for our last example, the intersection of 1, 2, and 2, 3 is just 2. It's only what's in set A and set B.
And finally, there's difference. This one lets us isolate what's unique to a single group. So if you take set A minus set B, you're basically asking, what's in A that is not also in B? With our example, if you take 1, 2, and subtract 2, 3, you're just left with 1. It's what's left behind after you take away the overlap.
And that's pretty much it, with just these 3 operations. Combining everything with union, finding the overlap with intersection, and finding what's unique with difference, we have a complete toolkit for figuring out how any 2 groups relate to each other.
All right, our toolkit is ready. Let's get back to that confusing survey and use these ideas. We're about to find out exactly where those 2 extra students were hiding.
And here it is. The most important clue was buried right there in the results. It says there were 10 choices for music and theater. That one little word, and, well, that changes everything.
This is it. This is our intersection. This is the overlap. It means that 10 students were counted twice. They raised their hand for the music group, and then they raised their hand again for the theater group. This is where our phantom students were hiding all along.
Okay, so now that we know that, we can ask a much smarter question. If we know 30 students in total chose music, but 10 of them also chose theater, well, how many of them chose only music? This is where we use our difference tool. We take the 30 total music choices and we subtract the 10 students who are in that overlap. And just like that, we find out that 20 students chose music and only music.
And we can do the exact same math for the theater group. We know 22 people picked theater, but that number also has that same overlap baked into it.
So we just take the 22 total choices for theater and we subtract those same 10 students who were in the intersection. And that tells us that 12 students were interested in only theater.
So now let's add up our real numbers. We've got 20 students who chose only music, 12 who chose only theater, and the 10 who chose both. You put those all together, and you get 42 students who actually made a choice.
And here is the final piece of the puzzle. If 50 students were surveyed in total, and only 42 of them made a choice, well, that leaves 8 students who didn't choose music or theater. And just like that, the mystery is solved. No phantom students, just simple, overlapping choices.
Now, this whole idea, this way of being really precise about what's in a group and what's out, it's not just for counting people. It is a fundamental concept all across mathematics, especially when we talk about numbers on a number line with something called real intervals.
Check this out. A closed interval, the one with the square brackets, includes its endpoints. Think of those brackets like solid walls. The numbers a and b are definitely part of the set. But an open interval, with the parentheses, excludes them. It's the same exact logic, using clear symbols to define exactly what's in the group and what's not.
And that's really what this is all about. It's not just about solving some little puzzle. As Professor Freitas says here, learning this symbolic language, it gives you a kind of mental maturity. It's a way to think with absolute precision, and that's a skill you can apply pretty much anywhere.
And once you start to see it, you'll realize this logic is everywhere. The next time you see your overlapping circles of friends on social media, or you see a movie that's listed in both the comedy and action categories on Netflix, you'll know that the simple, powerful language of sets is at work. So the only question left is, where will you spot it next?